Screen recording, I'm going to show you how to investigate the velocity and acceleration graphs based off the position. So starting where we left off, I have my function entered here, s of t, and this is the position function. So you enter a time t into this expression, and it outputs the position. So after maybe 5 seconds, you plug in 5 in for t. We can actually drag c over t equal 5. You can see, okay, when we plug in 5 there, it looks like our position would be at 400, which is 400 feet above the ground. Now, position is one interesting thing about this, but we also want to investigate the velocity and acceleration to see how fast is this going and at what rate is it accelerating. Desmos is great for this because it can calculate the derivatives for us. So the first one I'm going to do is v of t. This is going to be my velocity graph. I'm going to set that equal to the derivative of the position graph. Because if I find the rate of change of the position graph, that would be how fast it's changing based on the time, which is just speed, or more specifically velocity. So I'll take d dt, so I'm taking the derivative with respect to t of the position function, s of t. Enter, and you can see it automatically pops up there. If I want to zoom out, I can adjust my window. There we are. Let me make this a little bit bigger here. Similarly, set up my acceleration function, a of t. The acceleration is going to be the rate at which my velocity is changing. So this is going to be the derivative with respect to t of my velocity. It's the rate of change of the velocity, or another way of thinking about the acceleration, it's the second derivative of the position. It's the derivative of the derivative. I hit enter there, and now I can see the three different graphs here. If I pull C back, we can still watch C, but it would be nice here to see, okay, for all these times, what is the position, what is the velocity, and what is the acceleration. So what I'm going to do is I'm going to set up 3 more points. I'm going to have, as C gets bigger, the points actually follow on each of these different graphs. So my first one is going to be the point C, comma, this one follows the position, so S of C, and you can see that pops up right over here. I'm going to change the color to that just to make it match. So if you click and hold on the color next to it, you can change that to being red there. Okay. I want to put a point on the velocity graph. So this would be the point C, comma, v of C now. So the velocity at time c. Again, that's on my purple graph, so I'm going to hold to make it purple. And the final ones I want to point on my acceleration graph. So that'd be c, comma, a of c, which would be at time c, what is the acceleration? Right. That one wants supposed to be orange, so I'll click and hold to turn that guy orange. Right. And so now what I can do is I can drag C, and I'm going to see a few different things going on. As I move it, I'll see this is the animation of what's actually happening with the object. So it's getting shot up, and then it's coming and falling back down to Earth. And I can also follow, okay, as the time goes on, right here is this position, so it's the same height. The purple, this would be its velocity at that time. So you can see what the velocity is. You can look here, it's going about 100 feet per second. Then we can look at the acceleration, which is down here. So if I pull this over and I hit play, you can get an animation to see at any given time. So this is when C is about 8.25, so 8.25 seconds after the blast. You can estimate from here what is the position, how high above the ground is it, what is the velocity, and then what is the acceleration.